Testing 1, 2, 3. Hey, welcome back to Dave's Data Analytics channel. This is night 2 of our chapter by chapter, exercise by exercise or walkthrough of the book entitled R for Data Science by Hadley Wickham and another gentleman. This, for lack of a better term, this is sort of the Bible of R for Data Science and R for Data Analytics. What the inspiration for this series, this complete chapter walkthrough of is this video right here. How to learn R free and easy and free. Well, his point is you get the data, you go online, you know his thing is you use the online version of that book, R for Data Science, and you literally start with page 1, and you read and work your way through the entire book to get to the end. By the time you will have a good foundation in R programming. Okay, that's his basic point. Does it work? Yeah, I know for a fact that this type of stuff works because many years ago, uh, that's how I learned to do Bash shell programming in Unix. I got a book on Bash shell. I started at page 1. I went through like half the book, and writing, typing out every single example code and everything like that. So, I'll go ahead and put a link to this video into the chat session. Okay, and there's the link to that book. Now, so now let's go out and let's find the book. Okay, so go to your favorite search engine or whatever and type R, the number 4, DS for Data Science book. And here it is. Welcome to R for Data Science. You notice the URL up here? Okay. So we come here to this, we come here, now we're to the online version of the book. Okay. What else should we look at before we get started here? Seemed like there was something else I needed to talk about. Okay, I guess I'll say the objective is to, they always say, right, under promise over perform. So I'm going to under promise by saying 1 chapter a week and and some of the exercises. Maybe just one of the exercises. Yeah, that's really underperform here. It's really under promise here. 1 chapter a week and 1 exercise a week. So if we do a chapter and a half and 2, hey, then we overperformed, right? So anyway, last night we went through the introduction here. I will just point out now, if you get the printed version of the book, this introduction is not numbered. This and this section and this section and in the book, this is chapter 1, just not to be confused. So anyway, so now we got the book. Let's get ready to read some code. Introduction. The goal of the first part of this book is to get you up to speed with the basic tools of data exploration as quickly as possible. That is absolutely true. Okay, Hadley does not waste a lot of time with theory and stuff like that. Okay, data exploration is the art of looking at your data and rapidly generating a hypothesis. Okay, quickly testing them and then repeating again and again and again until you get the answer. The goal of data exploration is to generate many promising leads that you can explore in depth. So, so here's his data science life cycle. Import the data, tidy the table, transform the data, visualize the data, communicate the results, then do a model and repeat. In this book, in this part of the book, you will learn some of the useful tools that have an immediate payoff. Absolutely true. Visualization is a great place to start with our program because the payoff is so clear. You get you get to make elegant and informative plots, also called data visualizations, by the way, that help you understand data. In data visualization, you will dive into visualizations and learn to build you learn the basic structures of a GG2 plot, a powerful technique for turning data into plots. Visualization alone is typically not enough. So in data transformation, you'll learn the key verbs that allow you to select important variables, filter out key observations, create new variables, and compute summaries. Finally, in the exploratory data section, program, model, communicate, okay? You'll learn the key verbs and compute summaries. Finally, in the exploratory data analysis, you'll combine visualization and transformation with your curiosity and skepticism to ask and answer interesting questions about the data. Modeling is an important part of the exploratory process, but you don't have the skills to effectively learn or apply it yet. We'll come back to it in modeling once you're better equipped with more data wrangling and programming tools. Nestled among these three chapters that teach you the tools of exploration are three chapters that focus you on our workflow. In workflow basics, workflow scripts, and workflow projects, you'll learn good practices for writing and organizing your R code. These will set you up for success in the long run, as it will give you the tools to stay organized with your when you tackle real projects. Okay, I want to mention one more thing here, one more tool that can be of help. If you go to our tools, okay, if you go to GitHub, again you type R for data science, you hit enter. This is a source code for Hadley's books, okay? But what we're interested in is R for data science solutions. This one down here, okay? This contains a chapter by chapter, the code for every single chapter, okay? So what you could do, you can come up here, and you may want to do this. You can, if you know how to use Git, you can clone the GitHub repository, or you can download it, okay? And like I say, another way to learn this would be to go through this here and rewrite every single line of code again, okay? You can also use it if you reach a point where we're struggling with the quote with a description for a particular code or something like that. We can go over here and we can look it up. Okay, so that's something else you can do. So now let's come over to well, it says chapter 3, but I'm not sure if that's 3 or just. I guess it's chapter 3, introduction. The simple graph has brought more information to data analyst's mind than any other device. This chapter will teach you how to visualize your data using ggplot2. R has several systems for making plots. for making graphs, but ggplot2 is one of the most elegant and most versatile. ggplot2 implements the grammar of graphics, a coherent system for describing and building graphs. But ggplot2, you can, you can you can do more faster by learning one system and applying it in many cases. If you'd like to learn more about the theoretical underpinnings of ggplot2 before you start, I recommend reading the layers of grammar of graphics. This chapter focuses on ggplot2, one of the core members of Tidyverse. To access the data sets, help pages, functions, okay, that we use in this chapter, load Tidyverse by running this code. Okay, let's start by creating a new R Markdown file. Okay, let's get rid of all this. Okay, so let's go ahead and load the library. All right. And now you see all the packages here. All right. Now, one line of code loads the core tidyverse packages, which you will use in almost everyday analysis, which you will use in almost everyday analysis, every data analysis. It also tells you which functions from tidyverse conflict with functions in base R, or from other packages you might have loaded. If you run this code and get an error message, there is no package called Tidyverse. You need to install it, okay? We should have already done that, right? Very good. Okay, good. So you can see here, let me see something. You only need to install a package once, but you need to reload it every time you start a new session. If we need to be explicit about a function or data set comes from, we'll use the special form package.function. For example, ggplot tells you explicitly to use the ggplot function. First steps. So here we are. We're in the second chapter we're reading here, the third chapter, and we're already introduced to a data set. Okay. Let's 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 use our first graph to answer questions. Do cars with big engines use more fuel than cars with small engines? You probably already have the answer, but try to make your answer precise. What's the relationship between engine size and fuel efficiency look like? Is it positive, negative, linear, or non? This sounds vaguely familiar from a statistics class I started to take. Okay. uh, Now, the MPG Data Frame 3.2.1. You can test your answer with the MPG data frame found in ggplot2, aka ggplot2, uh, ggplot2 : MPG. A data frame is a rectangular collection of variables in columns, observations, and rows. MPG contains observations collected by U.S. Environmental Protection Agency on 38 models of a car. So let's just come down here, insert our first code. Now, don't worry about what I'm doing here so much. Okay. Okay, so don't worry about this too much. I'm using what's called our markdown, but you can so anyway, so you can see here. Here's the information for our models, all the way up to class. Okay, and here we see it here. Among the variables in MPG are displace, the car's engine size in liters, highway, the car's fuel efficiency on a highway in miles per gallon. A car with low fuel efficiency consumes more fuel than a car with high fuel efficiency when they travel the same distance. To learn more about MPG, open it in a help page by running MPG. Okay. You can come down here, and this tells us the rows and the variable names. Manufacturer, model name, displace, engine displacement in liters. So we're measuring distance in miles per gallons, but the engines being the size is being based on liters. Year, the year of manufacture, number of cylinders, the transmission type, drive, city miles per gallon, highway miles per gallon, fuel type, and the type of car, the class of the car. Okay. Created ggplot2. So here we are. We're barely into the book. We're already looking at our first piece of code. Okay. So we can cut and paste this, or we can type it in. Okay. Now I'll just mention right here that you don't need the data flag and you don't need mapping. So you don't need data equals, you don't need mapping to equal. You can just put the now there are, well, let's just leave that right now until it doesn't work. Okay. MPG, then we go say underscore displace. So highway. Okay. Congratulations. You just wrote your first code. Okay. So what we got here? The bigger the displacement, the lower the mileage. Okay. Well, we do have this kind of odd one up here, displacement, which gets high mileage. Okay. You got these over here, which is kind of have a larger displacement in liters, but they have better mileage. We'll talk about that later on. Okay. So congratulations, you just created your first plot in R. Okay. You can move to the head of the class now. The plot shows a negative relationship. The reason it's called negative is because it's declining, okay? That's actually a statistical description. It's negative because the numbers are generally trending downward, okay? The plot shows a negative relationship between engine size, displacement, and fuel efficiency highway miles. In other words, cars with big engines use more fuel. Does this confirm or refute the hypothesis that about fuel engine? I would say it overall confirms it, except for a couple exceptions. Okay, so now with ggplot2, you begin to plot with function ggplot. ggplot creates a coordinate system that you can add layers to. You can also think of the coordinate system as being like a blank canvas, like a painter would use. Okay, that's not necessarily any easier, but that's just one way to think about it. The first argument ggplot2 is the data set to use in the plot. Okay, data equals MPG. Again, you don't need to put data in there. Okay, creates an empty graph, but it's not very interesting, so I'm not going to show it here. Okay, what you could do over here. Okay, you could come over here. Okay, you could come over here in the console, right, and do this. Okay, so we've created a blank the ggplot creates a blank canvas with the coordinate. You can't see the coordinate, but it is x and y coordinates on the plot. Okay, so that's the first thing to keep in mind. Okay, the canvas. Then let's just keep reading on here, shall we? I want to try to get in the way of. You complete your graph by adding one or more layers to ggplot2. The function geom_point. Oh, by the way, this is also a scatter plot, okay? Adds a layer of points to your plot, which creates a scatter plot. ggplot2 comes with many geom functions that each add to different types of layers or to a plot. You will need to learn a whole bunch of them throughout this chapter. You will learn a whole bunch of them throughout this chapter, okay? Each geom function in ggplot2 takes a mapping argument. This defines how variables in your data set are mapped to visual properties. The mapping argument is always paired with AES, or aesthetics, and X and Y assignments of AES. Specify which variables to map on the X and Y axis. ggplot2 looks for the map variables in the data argument. In this case, MPG. In this case, okay, good. I wanted to make sure that so congratulations, you just learned the most important part about ggplot2. If you understand this first section, you're well on your way to learn to creating really nice plots and data visualizations. Okay. Let's see, 3.2.3, a graphing template. Let's turn the code into a reusable template for making graphs with ggplot2. To make a graph, replace the bracketing sections in the code below with a data set, a geom function, and a collection of mappings. Okay, so that's what this looks like. Okay. Uh-oh, here we go. Exercises. Look at this. We're not even 10 pages in. He's already throwing some exercises at it. What did we see? We saw a blank canvas. Okay. How many rows are in the MPG data set? Well, how many rows are there? We can use a function called, well, I mean, he hasn't mentioned this, but this is what you can do. Okay. So there's 234 rows and 11 columns of variables. Okay. I mean, we could have just done this up here, probably got the same information. Yeah, same thing. 234 rows by 11 columns. Okay. What's next? What does the drive variable describe? I believe that's is that the transmission? The type of drive train. Okay. F is front wheel drive, R is wheel wheel drive, and and R equals four wheel drive. So what do we got here? Suppose we come back up here then and replace this with drive. So of course, nowadays in America, not a lot of cars have wheel wheel drives. Okay. All right. That may or may not be helpful, but that's just, again, it's just all they did was change one variable out. Okay. What else? Let's see something here. Now, make a scatter plot of highway and cylinders. Okay. Now you can do all this stuff in a plain script file also, which isn't a bad place to start. Okay. And he says highway and cylinder. So I'm going to assume CYL. Because cylinders, of course, is related to engine size. So why is there a blank at 7? There's nothing there. Okay. Well, are you sure it's not useful? Why is this plot not? Useful because both variables are categorical. Okay. We haven't actually discussed categorical variables yet. That's kind of curious. Okay. Uh, a categorical variable is a variable. In one sense, it's a variable you can't perform math. You can't perform math on. So if you look over here, there's obvious categorical variables. Okay. The car manufacturer's categorical. It's a limited range. The model is. Uh, what about years categorical, right? The year of manufacture, uh, transmissions categorical, drivetrains categorical, so forth. Okay, highway, fuel type, class, and class. Among other things are categorical variables. What's numeric variables? Yes, displaced, year. I don't know if that's true because year has a limited range in it. Okay, but okay, we'll leave it there for right now. Okay. Now, of course, he didn't introduce. Well, I maybe So he didn't. We weren't actually introduced to categorical variables or continuous variables. Okay, uh, but one thing you can on a continuous variable, numeric variable, you can perform math functions. On a categorical variable, you can't. Okay, you can't add 4 cylinders and 6 cylinders. It gives you 10 cylinders. Okay, so okay. Aesthetic mapping. The greatest value of pictures is when it forces us to notice what we've never expected to see. In the plot below, one group of plots highlighted in red seems to fall outside of the linear trend. These cars are higher mileage than might be expected. How can you explain this? Well, these are well as you well. Let's just come down here. Let's just keep reading. We don't want to answer the question before it's. We don't want to answer a question before it's asked. Okay. Uh, let's hypothesize that the cars are hybrids. One way to test that hypothesis is to look at the class value of the car. The class variable of the MPG dataset classifies cars into groups such as compact, midsize, SUV. If the out if the outline points are hybrids, they should be classified as compact cars, or perhaps some subcompacts. Keep in mind that the data was collected before hybrid trucks and SUVs were popular. You can add a third variable like class, okay, class, to a two-dimensional uh, scatter plot by mapping it to an aesthetic. An aesthetic is a visual property of objects in your plot. Okay. Aesthetics include things like shape, size, and color of your points. You can display a point like the one below in different ways by changing the values of its aesthetic properties. Since we already used the word value to describe the data, let's use the word level to describe aesthetic properties. Uh, Levels. Okay, well here we change the level of a point size, the shape and color to make the point small, uh, triangular, and blue. Okay. You can convey information about the plot, about your data. I keep trying to read ahead. About your data by mapping aesthetics. Sorry about that. I didn't realize I was okay there. Okay. Let's go back. You can convey information about your data by mapping the aesthetic in your plot to variables in your data set. For example, you can map the colors of the points of the class variable to reveal the class of each car. Notice the location of color. Okay, it's inside the aesthetic mapping. Okay, so let's come back over here to the original number, displacement highway. Displacement. DIS. Notice I'm typing in all the code. That's the key to learning, typing in all the code. Okay? So let's see what happens now. Okay, so some of these are sports cars. Okay. Yeah, it looks like the SUVs are down here, okay? If you prefer British English like Hadley, you can use collar instead of collar. To map an aesthetic to a variable, associate the name of the aesthetic to the name of the variable inside the AES aesthetic uh, uh, part of the plot. GG2 will automatically assign a unique level of the aesthetic, here the unique color, to each unique value of the variable, a process known as scaling. Okay, ggplot2 will add a legend. That's very important. Legend that explains which levels are components. So let's take a look at the see what he's talking about, the legend. So you don't have to do anything to create a legend and ggplot2. All you got to do is add a map, add a class, either add a color or a fill class, a fill. Okay. No, I'm not going to do it for fill. We didn't talk about forget I said fill. Okay. So once again, we're barely into the work, and you already know a lot about ggplot2. I mean, to a certain extent, you already know everything you have to do to create plots of your own data. Because if you can understand the aesthetics and the X and Y mappings, you know what? You already know 90% of ggplot2. Okay? All you got to do is find some data and start plotting it yourself. Okay? The colors reveal that many of the unusual points are two-seater cars, little sports cars. Okay? These cars don't seem like hybrids, and in fact, sports cars. Okay? Sports cars have large engines like SUVs and pickup trucks, but small bodies like midsize and compact, which improves the gas mileage. In hindsight, these cars are unlikely to be hybrids since have large engines. Okay. Now, in the above example, we map class to color aesthetic, but we could have mapped class to the size aesthetic in the same way. In this case, the exact size of each point would reveal its class affiliation. We get a warning here because mapping an unordered variable to an ordered aesthetic is not a good idea. Well, we'll see about that. Okay, so we're going to come up here. We're going to replace color with size. Did I get a warning? Okay, so now you can see the two-seaters have the smallest dots. Why not? Or we could map class to the alpha aesthetic, which controls transparency of the points, or to shape aesthetic, which controls the aesthetics, which controls the shape of the points, left and right. Highway alpha class, highway shape class. Okay, so let's just do this. So you see how the different dots are how bright they are and dark they are. Okay. What's the last thing? Shape the class. and shape. Now, so it gives us a different shape. Now this is actually easier to read, of course, but unless I'm mistaken, there is a limited number of shapes. Okay, all right. What happens to the SUVs? What happened to SUVs? ggplot2 will only use 6 shapes at a time. By default, additional groups will go unplotted when you use the shape aesthetic. So that's a problem in it, okay? For each aesthetic, you use an AES function to associate the name of an aesthetic with a variable to display. The AES function gathers together each of the aesthetic mappings used by a layer and passes them to the layer's mapping argument. The syntax highlights a useful insight about X and Y. The X and Y points, the locations of points are themselves aesthetics, visual properties that you can map to variables, display information about the data. Now, you can also set the aesthetic properties of your you can also set the aesthetic properties of your geom manually. For example, we can make all the points blue. Notice what he did there? Outside of the aesthetic, he said, right, remember inside of here we had color, which set the color for class or shape, okay? Notice it's located inside the AES function. If you simply want to set a color, okay, see if this works. So let's get rid of this. Color or not colors. Now this sets the whole, notice what it does, it sets all the points to blue, okay? Uh-oh, we got some exercises coming up. So there's 10 sections to this chapter, and we're on number 3. Okay. Here the color doesn't convey information about the variable, but only changes the appearance of the plot. To set an aesthetic manually, set the aesthetics by name as an argument of your geom function. It's outside of AES, right? You'll need to pick a level that makes sense for that aesthetic. The name of a color as a character string. The size of the point in mm. Okay. The shape of the point as a number shown in 3.1. Will this work? It does work. So I set the shape outside of again outside of the aesthetic, and it changed the type of how the point is displayed. Okay, let's do this. Now we got red triangles. Suppose we said fill. Do you see the difference? With this, with the collar, it collars the borders of the dot. Fill fills in the dot, but you know if you look carefully, see there's still a black border. Okay, so we would have to do like red collar, red fill, or something like that. Okay, there I am sneaking ahead again. I figured that's one. Okay, exercises, exercises. Okay, 3.1 has 25 built-in shapes that are identified by numbers. There are some seemingly duplicates. 0, 15, and 22 are all squares. 0, 15, and 22 are all squares. The difference comes from the interaction of the collar and the fill aesthetics. The hollow shapes, 0 and 14, have a border determined by collar. The solid shapes, 15 to 20, are filled with collar. The filled shapes, 21 and 24, have a border collar and are filled with fill. So here's the question. What's wrong with this code? Why are the points not blue? Because the collar, because this needs to be located outside of the aesthetic. Okay. Which variables are categorical? We've already discussed this, haven't we? Which variables are continuous? Does it actually help? Okay. We can come back over here to answer that question again. The categorical variables are variables that have a limited number of things and they cannot be used to do for mathematical functions. So the models are categorical. The cylinder is, you can't add 4 cylinders plus 6 cylinders to get 10 cylinders. Obviously manufacturer, transmission, the drive type, uh, what's FL? Fuel type, and the class. So they're saying that continuous variables, the numeric are displacement in liters, the year. Yeah, but year can also be categorical because there's a limited range of years for the data. City miles, of course. Map a continuous variable, the collar size and shape. Continuous variable, the collar size and shape. Well, highway is a continuous variable, right? Okay, so that's sort of interesting, isn't it? Don't read more into these exercises. It's actually their collar. Okay. Oh, interesting. So continuous variables cannot be mapped to shape. Okay. So what do we do? We did this. Let's see. Well, you can't map shape to a continuous variable. Okay. What happens if you map the same variable to multiple aesthetics? Well, depending on the variable, it'll. I mean, if you come in here and do, will this work? Okay. It plots. What it does, it plots both aesthetics for the same variable. Okay. Let's see. So, what happens if you map the same variable? What does the stroke aesthetic do? What shapes does it work with? Hint. Zoom point. The stroke aesthetic. I didn't know there was a stroke aesthetic. Hmm. I didn't know there was a stroke aesthetic. Good grief. Hmm. That's interesting. What the, what does the hmm. I didn't know about the stroke aesthetic. What is stroke? Hmm. You know, this is one of those times when you come over here. We're probably just confusing ourselves here, actually. Let's come back over here. See if we can get the answer to that question over here. Stroke controls the width of the border of certain shapes. These shapes which have borders are the only ones that the stroke alters. What happens if you map an aesthetic to something other than a variable name? Okay. Gee, I don't know. Let's see what happens. My guess is it's only going to map displacement less than 5 liters. How do you describe this? Oh, hey Juan, how you doing this evening, friend? I'm continuing to work my way through chapter by chapter through a book called R for Data Science. I'm doing well, friend. I decided to take on the task of doing a series of videos where I walk through chapter by chapter a book called R for Data Science. Uh, and so far I'm doing okay. Note you also need to specify X and Y. Okay. Common problems. As you start to run R code, you'll likely run into problems. Don't worry, it happens to everyone. I have been writing code for years, and every day I still write code that doesn't work. Start by carefully comparing the code that you're running to the code in the book. R is extremely picky, and misplaced characters can make all the difference. Make sure that every left bracket has this, and every quote is paired, and another. Sometimes you run the code and nothing happens. Check the left hand of your console. If it's a plus, oh yes, it means that R didn't think you typed a complete expression, and it's waiting for you to finish it. In this case, it's usually easy to start from scratch again, pressing the escape to abort the process. Okay, I didn't actually know that. So how was class today? Oh, good. That's good. Okay. One common problem. What work? I don't work for a living. I'm retired. Not much has happened. I just just did my COVID-19 analysis videos earlier today, and like I said, now I'm working on this book called R for Data Science. I'm going to do a whole series of videos and basically do a chapter by chapter walkthrough of this whole book. At least that's the plan. Eh, nothing to be sorry about. I'm paid. The government pays me not to work now. It's called retirement, Social Security. Okay, well, actually not paying me. They're actually. Actually, the government's paying me back the money I paid in for after 30 years of work. So yeah, it's in the U.S. It's called Social Security. And when you get to be 62 and a half, you can stop working, and they'll give you a monthly check. They'll send you a monthly check for all the work you've done for the previous 30 years. Is to put the plus side in the wrong place. It has to come at the end of a line, not the start. In other words, make sure you haven't. Okay, good. How old do you have to be? So let's just run this and see what happens. So we can see the error message. Error cannot use plus GG2 with a single army. Did you actually put the plus on a new line? Yes, we did. That's exactly what he's talking about. If you're still stuck, try to help. You can get help about R functions by running question mark function name in the console, or selecting the function name and pressing F1 in R Studio. Don't worry if the help doesn't seem to be that helpful. Instead, skip down to the examples and look at the code. You need to be 60 if you're a man and 55 if you're a woman. Wait a second, that doesn't sound fair to me. How come women get to retire earlier than men? There's something wrong with that picture. Yeah, I retired at 62 and a half, and if I waited to 65 or 67, say, I would have gotten more money per month, but I didn't want to wait. Don't worry if the help doesn't seem helpful. I give you a heads up. A lot of times the help isn't very helpful, and sometimes even the examples aren't helpful, but they do sometimes help. If that doesn't help, read the error message. Carefully read the error message. Sometimes the answer will be buried there. That's very true. Okay, but when you're new to R, the answer might be in the error message, but you don't know how to understand it. Another great tool is Google. Absolutely, cannot emphasize Google and YouTube enough. Try Googling the error message, as it's likely that someone else has had the same problem and has gotten help online. Now we're adding a new facet, if you pardon the expression, to our plots. So you've really learned a lot about ggplot2 already, and this is going to continue through the rest of this thing. Facets in geometric objects. Okay, so we are going to try to get through the entire chapter tonight. But like I say, you notice there's a lot of code and a lot of visualizations. 62 and a half. One way to add additional variables to each aesthetic, another way particularly useful for categorical variables, is to split your plots into facets, subplots that each display a subset of the data. This really is useful. Okay, this is a very useful function. To facet your plot by a single variable, use the facet wrap command. The first argument of the facet wrap should be the formula which you create with the tilde, okay, followed by a variable name. Here, formula is the name of a data structure in R, not a symbol for an equation. The variable you pass to the faster app should be discrete. So here's the plot again, okay? And we've already got this part here, right? Now we're going to do a faster app by class, and you can see the classification of the car. So let's come over here now. Let's take this variable right here, okay? Copy that, put that down here, okay? Facet wrap, tilde, okay? Let's see how this works. So now you got in this. So this is this the facet wrap is a very useful function. I know you use it a lot of times just for this information, just because of something like this. Okay. Now over here, notice he says number of rows equals 2. Let's try number of rows equals 2. In row. Oh, did you notice the red line over here? That's a hint as to where the problem is. And when you enter the correct who was that? Nah, let's see something here. So now we got 2 rows. Now automatically split it out to 2 rows, and uh, so so now you got this nice plot with all your categorical all your discrete variables plotted out here. We could also do, I believe, COL. Okay, see what this does. Now it puts it into 2 rows, 2 columns. Okay, see if it probably says something about that down here. Okay, so that's one way of doing it, right? To facet your plot on a combination of 2 variables, add facet grid to your plot call. Oh, okay, 2 variables, add a facet grid to your plot call. The first argument of facet grid is also a formula. This time, the formula should consist of 2 variables separated by a tilde. Okay, so let's do drive. Facet. Okay. And we're going to do it by drive and cylinder. Let's see if this works. Oh, you notice how the chunk didn't run? If that happens, it means you're probably missing a backtick someplace. Okay, she got the displacement up here, right? And you got the cylinders up here and the drivetrain here, okay? 4-wheel drive, front-wheel drive, rear-wheel drive, four, 4, 5, 6, 7, 8 cylinders. Okay. So again, I want to emphasize how how much we've learned so far, even at this point. Okay. If you prefer not to facet in rows and columns uh, dimension, use the period instead of the variable name. Hmm. Okay. Hmm. That is interesting. Okay. Exercises. What happens if you facet a continuous variable? What is it? It's what happens if we try to do a facet by a holy smoke? That's interesting. I don't know if it's useful, but it's helpful. Let's see what it says over here. Hmm. It plots it anyway. What does the empty cells in the plot with facet mean? How do they relate to this plot? It means that there is a combination where there are no data points. What plots does the following code make? Does it? Okay. Okay. What do the empty cells in the facet grid? Yeah, it means that there's no variable for this displacement and this drivetrain. Okay, right. What plots does the following code make? What does do? Well, let's come back over here again. Hmm. One more time. What plots does the following code make? Well, I mean, it makes a drive. So this is the drive, and this is the displacement in liters. Is there another way to do this, though? Well, it makes scatter plots, okay? Not quite sure how to describe that. Okay, let's come down here. Okay, and rows or columns. For example, facet we use drive as rows, while facet grid, we use it as columns. Okay, very good. Facet grid tilde drive will do the same as a column faceting using the facet grid drive tilde. Won't because the formula object needs to be something other than a tilde. Okay? Okay. That makes sense, I guess. Let's see something here. Let's just look at both of these plots here. See exactly what goes on. Okay, so the period before plots a cylinder in columns. But the period after the tilde plots the drive in rows. Okay, that makes sense. See, I've learned stuff I had no idea. I've been using ggplot for 4 or 5 years, and I didn't know this stuff. So, okay, take the first facet plot in this section. Okay, what are the advantages to using faceting instead of color aesthetics? What are the disadvantages? Okay, what are the advantages using a facet instead of a well? With the facet, you can have more subplots. Okay, there's well, you can balance by using the color aesthetic because each subplot contains its own little plot. It's obvious which data points are mapped to which plots. Okay. The faster app. What does inrow do? It uses it creates columns instead of rows. What other options control layout of the individual plots may be? Okay, so let's come back over here now. Let's just read the answers here. What are the advantages of using a faceting instead of a color aesthetic? What are the disadvantages? How might the balance change if you get larger data sets? I think faceting is better when you want to pay a particular attention to a particular facet alone naturally, while using the color aesthetic to better discriminate which points are located where. Color is better to give the global overview of the relationship with faceting, while faceting is better for paying attention to whichever group within the group patterns. For example, fitting many trend lines for different groups is better done with faceting altogether. Okay. Okay. Read faster. What does in row do? What does column rows do? In rows controls the number of rows for the total number of facets. In column controls the number of columns. Other options can be control interesting parameters. For example, scales can control whether each plot has its very own axis. Right, as it does. Okay. As in allow axis to be free. The function has the labeler option to change the names of each facet and other options like strip position for positions of facets labels. Read facet wrap for more options. Okay. Hmm. How do you change the names of facets very easily? Hmm. Interesting. As a labeler, it looks a lot like recode. Okay, but that looks okay. Hmm. No, does he actually mention? Hmm. I don't see the bonus question there. Huh. Interesting. Okay. Hmm. 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 Okay. Hmm. Okay. Good. Okay. Let's continue on over here now. 3.6 Geometric objects. Well, because a plot's wider and it's longer. How are these two plots familiar? Well, they both show what the data is doing. Okay. These two are actually the same plot. This simply shows a trend line, and you can see the underlying trend here also briefly. Okay. All right. Both plots contain the same x variable, the same y variable, and both describe the same data, but the plots are not identical. Each plot uses a different visual object to represent the data. In ggplot2 syntax, we say that they use a different geom. Right. So a geom is a geometric object that a plot uses to represent data. I'll be right back in this 1 minute, Juan. Okay. Okay, where was I? So both plots are the same x-axis, geom. A geom is a geometric object that a plot uses to represent data. People often describe plots by the type of geom that the plot uses. For example, bar charts use bar geoms and line plots use line geoms. Box plots use box plots geom and so on. Scatter plots break the trend. They use a point geom. As we've seen above, you can use different geoms to plot the same data. The plot on the left uses a point geom, and the plot on the right uses a smooth geom. The smooth line fitted to the data. To change the geom in your plot, change the geom function that you add to the ggplot. For instance, to make the plot above, use this here. Okay, so let's just run this here. So there's one. Now let's do the second one. And here's the second plot, okay? Now, every geom function ggplot2 takes a mapping argument. However, not every aesthetics work with every geom. You could set the shape of a point, but you cannot set the shape of a line. On the other hand, you could set the line type. Okay, geom smooth will draw a different line, a different line type. For each unique value of a variable that you map in a line type. So here it is again. Now I never actually thought about this either. Okay, so once again, let's take a look. Interesting. Four-wheel drive, front-wheel drive, rear-wheel drive. So that's interesting. What's interesting is, why does front-wheel drive dip and then go back up as displacement? So it seems to be you're okay up to displacement of 5 liters, but you go to 5 liters in front-wheel drive. Oh, and this must be those sports cars again, all right? Okay, so that's interesting. Okay, here Geon Smooth separates the cars into 3 lines based on the drive value, which describes the car's drivetrain: front wheel, four-wheel drive, rear-wheel drive. One line describes all the points with a 4 value at the 4 liters displacement. Okay, four-wheel drive. One line describes all those with front-wheel drive, and one line describes the points with rear-wheel drive. If this sounds strange, we can make it more clear by overlaying the lines on top of the raw data. Okay, then coloring everything according to the drive. All right, so So we can do this. Okay. Okay. So the drive's going to be in color. Hmm. Okay. My mind seems to be wandering a little bit now. Okay. Hmm. I seem to be missing something here. Let's see. It sounds strange. We can make more clear by overlaying lines on top of the raw data. Okay. Notice that this block contains two geoms in the same graph. If this makes you excited, buckle up. We will learn how to place multiple geoms on the same plot very soon. Okay. 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 So there now we got that plot over here. Okay. Notice the plot continue very soon. ggplot2 has over 40 geoms, and extension packages make even more. ggplot2 extension gallery for sampling. ggplot2 language. Okay. Okay. Oh crap! I just closed up the wrong thing. Jeez, oh Pete Jackson. Okay, facets, common problems, facets, geometric objects. If this sounds strange, we can. Many geomes, like GeoSmooth, use a single geometric object to display multiple rows of data. For these geomes, you can set the group aesthetic to a categorical variable to draw multiple objects. ggplot2 will draw a separate object for each unique value of the grouping variable. In practice, ggplot2 will automatically group a data for these geomes, whether you map an aesthetic to a discrete variable, as in the line type example. It is convenient to rely on this feature because the group aesthetic by itself does not add a legend. Now, here's what we're not really sure about. Okay, do you really have to use the group variable? Okay, so let's just come over here now. Okay, so here's our geom smooth. Okay, now we're going to do the geom smooth. We're going to do a group drive. Now the question is, do you really need both the? Okay, okay, so the group works, but it doesn't actually create a legend. So that's why you need geom smooth, color. But in this case, you don't need group, right? So here's the various groups, but there's no legend. Now we can do this and no legend. So you don't. So you don't really. So when do you use the group and when do you just use a color? Because the color function also does a group, right? To display multiple geoms in the same plot, add multiple geom functions to the plot. Yep, it's really obvious, right? Okay. This, however, this, however, introduces some duplication in our code. Imagine if you wanted to change the y-axis to display city instead of highway. You would need to change. There you go. You put the mappings up in the geomplot function. Exactly. You need to change the variable in two places, and you might forget to update one. You can avoid this type of repetition by passing a set of mappings to ggplot2. The ggplot2 will treat these mappings as global mappings that apply to each geom in the graph. In other words, the code will produce the plot, same plot. Okay. Okay. If you place mappings in a geom function, ggplot2 will treat them as local mappings for the layer. Okay, the aesthetic here is local. Good. It will use these maps to extend or overwrite the global mappings for that layer only. That makes it possible to display different aesthetics for different layers. Okay. Okay, so that makes perfectly good sense. Okay, let's just continue rolling along here. This is going to wind up being a really long recording again, but we are doing a walkthrough. Okay, it can use the same idea to specify different data for each layer. Yes, you can. Here are smooth line displays, just a subset of the map data set. The subcompact cars. The local data argument in geom2 overrides the global data argument. So we got this up here already, right? Now I have to be honest. I've never actually used a filter command inside of a plot function. Uh, and what does SE do? I can't remember what SE does. Okay, so we've already done this. So let's just copy all this then and do it over here again. Let's do it all for the fun again. So filter class equals subcompact. I don't remember what the SC represents, but maybe that's not important right now. Okay. You learn how a filter works in the chapter on data transformation for now. You just know that the command selects that this command selects only the subcompact cars. All right. What geom would you use to draw a line chart, a box plot, a histogram, an area chart? Well, the line chart would be geom line, the box plot would be geom box plot, and the histogram would be geom histogram. An area chart, oh, geom area. Run this code in your head and predict what the output will look like, and then run the code here. Geom, I don't recall what SC stands for. Let's come over here real quick. Okay, what does the SE stand for? SE displays confidence intervals around the smooth. Oh, okay, that's very important. What's a confidence interval? Well, a confidence interval is the shaded line. Let's see, come back up here. The shaded line is the confidence interval. That's what the SE variable's for. Because you look down here at these, and it says SE false. Now, why it's not a confidence CE, I don't know. What if it actually tell us that? Okay. Down here, you don't see the confidence interval. Okay, very good. Now, when you run this code in your head and predict what the output looks like, then run the code. So this is going to be, well, this is going to be a scatter plot, right? With displacement on X, highway on the Y, and the color is going to be by the drivetrain. Okay, so it's going to show a plot with the points. Okay, and the color of the drivetrain as points, and a geomed smooth without a confidence interval. So it's just I know what it looks like in my head. I'm just having trouble just getting this stuff to actually work. Let's see what we got here. Okay, good. Collared parts for the drivetrain, right? Four-wheel drive, front wheel, rear-wheel drive. We got the geo smooth without the confidence interval, and because the collar's up here, the geo it also affects the geo smooth lines also. Okay, very good. What does the legend false do? What happens if you remove it? What do you think I used it early? Why do you think I used it early in the chapter? I'm not really sure. The GM legend means it isn't going to print a legend out to the side. Okay? What does the argument GM smooth do? It creates a fitted or smooth curve, like a low-edge function or linear regression line. Well, these two graphs look different. Why and why not? Okay. Okay. These would be why or why not. So displacement y is highway. Yes, these should be identical. These should be identical. Okay? Because all you're doing, you're just splitting the aesthetics out into. Okay, recreate the R code necessary to generate the following plots. Yowza. Welcome back to. Okay, I'll be back in like 5 minutes. Now we get down to the nitty-gritty. Let's just delete. Okay. Okay. So let's take a look at these plots here. They all have the same x and y coordinates. All right? They all have the same x and y coordinates. Which means it's going to be DGPOT. But we don't actually have the answers to what the plots are supposed to look like, do they? Okay. Okay. So it's going to be MPG, comma, AES, comma, X equals displace, and Y equals highway, and Y equals highway. Right? Now, do these have anything else in color? Yes, the drive is going to be okay, and they all use drive. Up here, what's the difference between these two here? I can't really tell. So that looks right. Except this first one doesn't have that, does it? And this is a simple geode smooth, I think. Geode smooth. What's this? So that's basically that one there. And of course, there's no. So the next one is what? Hmm. We did that one back up here. Anyway. So what is this here? Is that displacement? Well, let's just try this. Let's just try doing a group displace. It's not a color. What is it? Let's say group drive. Oh, let's see something. Let's just skip down here. What gem would you use? So think about it. It didn't actually say it created a plot. Run this code in your head. No, they look the same. Recreate the code necessary to generate the following plots. Oh, okay. I was close. I was close. Okay. Now this here. So we can now do smooth. Let's do this. Okay. Okay, good. What about this? I think this would mean this would go someplace else. All right. Let's get rid of this. I don't think. Okay, good. Okay. So this is going to be smooth. What is it? Line type? Strive? AS, let's see. Let's see. Is this line type? So I don't know what this here is. That's just a straight plot. If we get rid of, oh, we get rid of smooth. Okay, good job. Okay, let's just keep rolling along here now. I'm actually fairly pleased with my exercise. I think the first one, but you know what? Uh, I can't emphasize how much we've learned so much so far. Okay, I was planning on stopping, but you know what? Hey, let's go ahead. Let's just keep this rolling. See if we can actually create finish the third chapter tonight. You know, the old adage is that the picture, is that the repetition is the mother in all learning. So that's as we continue to do more and more plots. So it'll become part of your own language. So now let's move on to 3.7, which is statistical transformations. Okay, statistical. Wait a minute. What are these diamonds doing here now? So we finished up with the cars, right? Okay, let's get rid of this now. Okay. Now let's take a look at a bar chart. Do we have to? Bar charts seem simple, but they are interesting because they reveal something subtle about plots. Consider a basic bar plot as shown in a geom bar. Okay? The following chart displays the total number of diamonds in the diamonds dataset grouped by cut. Okay? Okay. The diamond dataset comes with ggplot2 and contains information about 54,000 diamonds, approximately 50,000 diamonds, including the price, the carat, the color, the clarity, and the cut of each diamond. The chart shows that more diamonds are available with higher quality cuts than with lower quality cuts. Okay, so let's just run this real quick. First question is, do we actually know what the dimensions of diamond is? So what is the actual size of diamonds? 53,940 rows by 10 columns. Okay, good. So let's take a look at this right here. Notice in a bar plot, like this particular bar plot, you only have an X variable defined. Okay, so let's just take a look here. And here we have it. The ideal cut. So ideal is better than premium. So what this tells us is this is the number of diamonds in the database for each one of these cuts. Okay. Okay. Good. Now on the x-axis, the chart displays cut, a variable from diamonds. On the y-axis, it displays count, but count is not a variable in diamonds. Where does count come from? Many graphs like scatter plots plot the raw values of the data set. Other graphs like bar charts calculate the new values in the plot. Okay. Many graphs like scatter plots plot the raw values of your data set. Other graphs like bar charts calculate new values for the plot. Bar plots, histogram, and frequency polygons bin your data and then plot the bin counts, the number of points that fall in each bin. Smoothers fit a model to your data and then plot predictions from the model. Box plots compute the robust summary. That, of course, is interquartile range and medians, right? Yes, thank you very much. See, I have learned. I really should go back and finish that R for R for statistics course, because I have clearly learned some stuff. Okay. The algorithm used to calculate new values for a graph is called STAT, short for statistical transformations. The figure below describes how this process works with GeoMBar. So GeoMBar begins with the diamonds dataset, transforms the data with a count stat, which returns the set of count variables to count. And the GeoMBar uses the transformed data. Okay, very good. Hmm. Let's just do this. Is this actually a... So here you go. Table price. This is sort of interesting, isn't it? Huh. Let's take a look at string. STR stands for, I think, probably stands for structure. Okay. Hmm. Why is there an X, Y, and Z there? That's kind of strange. Okay. Okay. So you can learn which stat to use by inspecting the default value for the stat argument. For example, the geom bar shows the default value for stat is count, which means the geom bar uses stat counts. Stat count is documented on the same page as geom bar. And if you scroll down, you can see a section called computed variables. Holy smoke! That describes how it computes the two new variables, group and and proportion. Okay. You can generally use geom and stats interchangeably. For example, you can create the previous plot using the stat plot. Geom, okay, count. Okay, good. We're continuing to move right along here. This works because every geom has a default stat, and every stat has a default geom. This means that you can typically use geoms without worrying about the underlying statistical transformation. There are three reasons you might need to use the stat explicitly. You might want to override a default stat in the code below. I changed the stat of geom bar from count default to identify. This lets me map the height of the bars to raw values of the y variable. Unfortunately, when people talk about bar charts casually, they might be referring to this type of bar plot, which has the where the height of the bar is already present in the data, or the previous bar chart where the height of the bar is generated by computing rows. Okay, frequency. Okay, interesting. Okay, fair, good, ideal. Frequency. Okay. Okay. Okay, so this is still fine because you got the same results apparently. No, we didn't because, or maybe we did. Okay, identify. Don't worry that you might be able to guess at their meaning from the context, and you'll learn exactly what they are soon. Now, you might want to override default mapping from transform variables to aesthetics. For example, you might want to display a bar chart of proportion rather than count. Oh, this is interesting. I had no idea that you can do this. Now, why is a group equals one? Why is a group equals one? Hmm. Now, see, I learned something new here again. I knew roughly about this geo and bar thing, but I didn't know a little about stat, but I certainly didn't know that the stat could be proportion. Now, I'm not sure why the group is 1, okay? Because you see, this is now proportion or percentage of the total, okay? To find variables computed by the stat, look for the help section titled Computed Variables, okay? You might want to draw greater attention to statistical transformation in your code. For example, you might use stat summary, which summarizes the y variable values for each unique x variable to draw attention to the summary that you're computing. Stat summary, mapping, x, y, function min, function mat. Oh, that's interesting also. Function median. Hmm. But why is it not a bar plot? So this is almost like a bar. Well, this actually looks very interesting. Let's do this one also. Hmm, this could be useful. What's the function? Hmm, interesting. Okay, ggplot2 provides over 20 stats for your use. Each stat is a function, so you can get help for it the usual way. Two, list of stats. Try the ggplot cheat sheet. Okay, exercises. Where are we at here? 10:30. What is the default geom associated with stats summary? How could you rewrite the previous plot to use geom function instead of stat function? What is the default geom associated with stat summary? It's probably, you can get help the usual way, stat bin. What is the default uh, what is the default geom associated with stat summary? Let's come back over here then. What is the default geom for stat summary? How could you rewrite the previous plot? Is it? Hmm. Hmm. Okay, good. For example, plotting exactly x and y values. Aggregate data frame. Okay, I don't think that's actually part of the function. Let's see something here. In our proportion bar chart, we we need to set group to 1. Why? In other words, what's the problem with these two graphs? Okay, what's the question here again? In the proportion chart, in our proportion chart, we needed to set group equals 1. Why, in other words, what's the problem with the two graphs? There's nothing wrong with the two graphs. Okay. Most geoms and stats come in pairs. That is almost always used in concert. Read through the documentation to make sure. What does a geom smooth stat do? Hmm. Of all the pairs, what do they have in common? Okay, position adjustments. Okay, okay. After stat prop. Let's see something here. Okay. Now, are we doing too much reading in one night? Probably. Okay. Okay. So now, position adjustments. There's one more piece of magic associated with bar charts. You can color a bar chart using either color, aesthetic, or the fill. The color aesthetic, of course, just colors the borders, right? So what you can see here very carefully, uh, color just colors the borders, and fill colors the whole thing. Okay. Now, what happens if you map the fill aesthetic to another variable like clarify, and the bars are automatically stacked? Each colored rectangle represents a combination of cut and clarity. Fill. Okay, X cut, geom bar, X is cut, right? Fill clarity. Okay, good. Good. That makes sense. The stacking is performed automatically by the position adjustment specified by the position argument. If you don't want to stack, if you don't want a stack bar plot, you can use one of three options: identify, dodge, and fill. Okay. Position identify will place each object exactly where it falls in the context of the graph. This is not very useful for bars because it overlays them. To see that overlapping, we need to make the bars slightly transparent by setting alpha to a small value, or completely transparent by setting filled equals 0. Okay, let's take a look here. Hmm, good grief. Okay, identify alpha 1 of 5, position identity, diamonds cut color clarity. Oh, that's interesting. Hmm. Not necessarily useful, but it's interesting. Definitely an interesting twist. Okay. Now, the identity position, interesting. Now, position equals fill works like stacking, but makes each set of stacked bar charts the same height. Hmm. This makes it easier to compare proportions across groups. Okay, interesting. That's interesting. Let's see. Fill's clarity and position is fill. Huh, that's interesting. Position dodge places overlapping objects directly beside one another. This is what we need here. Bar mapping, clarity, fill, position dodge. Okay, so this is what we need. Fill, clarity, position dodge. All right, good. Good, 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 good. There is one other type of adjustment that's not useful for bar plots, but it can be useful for scatter plots. Recall our first scatter plot. Did you notice that the plot displays only 126 points, even though there are 234 observations in a data set? Yeah, I didn't notice that. Now that you mention it. Um, Coordinate systems, the layered grammar graphics. Okay, we're getting close to winding down this session for tonight. Okay. The values of highway display are rounded so that the points appear on a grid and many points overlap each other. The problem is noticed as overplotting. This arrangement makes it hard to see where the mass of the data is. All the data points spread equally throughout the graph. Ooh, the jitter. Of course, there's also a geo jitter right away. Let's point out. Yes. Okay, good. Combination. Highway displaced. It contains 109 points. You can avoid gridding by setting the position adjustment to jitter. Adds a small amount of random noise to each point. This spreads across points out across because no points are likely to receive the same number of points. Well, that's interesting. I don't quite understand. I still don't quite understand that, but let's just keep rolling right along here. Now, adding randomness sounds like a strange way to improve your plot, but while it makes your graph less accurate at small scales, it makes your graph more revealing at larger scales. Because it is such a useful operation, ggplot comes with a shorthand form of geomplot jitter called geomjitter. To know more about position instruments, look up the help pages associated with each adjustment: position dodge, position fill, position identity, position jitter, and position stack. Now, here we go. Exercise is 3.8.1. What is the problem with this plot? How could you improve it? What parameter of the geom jitter controls the amount of jittering? Well, let's come back over here. Take a look over here. What's the problem with this plot? How could you improve it? Although two variables are continuous, the chance of being in a single point is very discrete, and a lot of points overlap. We could fix it by adding jitter. Okay. What parameters to geom jitter control the height of jittering? Width and height. Okay, very good. Height and width. Hmm. What's the default position adjustment for geom box plot? Hmm. No, I have to tell you, I am starting to, my concentration is starting to waver. But let's go ahead and soldier on through these things here. We haven't talked about box plots. Hmm. Coordinate systems. Okay, coordinate systems. Coordinate systems are probably the most complicated part of ggplot2. The default coordinate system is the uh, Cartesian coordinate system where x and y positions act independently to determine the location of each point. There are a number of other coordinate systems that are occasionally useful. Coordinate flip switches x and y. That's right, it does. Very helpful, very helpful. Coordinate quick map, huh, sets an aspect ratio correctly for maps. This is very important if you're plotting spiral data. ggplot2, which unfortunately we don't have space to cover in this book. No! Map data MZ, ggplot NZ, longe latitude group, geopolygon. Let's take a look here. Okay. Geopolar uses polar coordinates to reveal an interesting connection between bar charts and coxcomb charts. Does it really? To me, this is more easy to understand than this. Although obviously, you know what this is? This is a bar plot. This is a pie plot. The only difference is you only have the slices are different sizes. It's a variation in exercises here. Turn a stack bar plot into a pie chart using polar coordinates. Whoa, 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 whoa. We don't need no stinking pie plots here. Okay? What does labs do? It allows you to set things like titles, X and Y labels. What's the difference between a quick map and a chord map? What does the plot tell you about the relationship between city and highway miles? Turn a stack bar chart into a pie chart using the coordinate folder. Hmm. Of course, you don't want to do this in the first place. Labs do. Yes, it does. What's the difference between a quick map and a coordinate map? A coordinate quick map is very similar to a chord map, but a chord that without plotting by straight lines. What does the plot below tell you about the relationship between city and highway miles? There is a positive correlation between the two. Coordinate fixed makes sure that there is no visual discrepancies and ensures that the ranges of the axes are equal to the specific things. Finally, geo maybe line plots do things. Okay, good. No, no, I have to be honest. I mean, I'm probably not going to remember a lot of this stuff tomorrow morning, but we really did. No, be honest. If you understand 50% of what this has said, you can do a lot. I've been programming for 4 or 5 years, and a lot of these things I've never used. Okay, I didn't know anything about quick maps or coordinate maps, anything like that whatsoever. But now I do have some information, and if I need to do something, I'll be able to go back and look for something, based on what I learned here. Of course, we probably learned a lot, but still, you know, you've learned a whole lot in about 3 hours worth of time. Okay, I'm probably going to slow down and start maybe really only doing uh, two, uh, at the most, two chapters a week, maybe only one chapter a week to really try to work a little harder on the exercises. But you know what? We're almost down to the minimum here now. And we're on 3, which is data visualizations. Let's see. In the previous sections, you learned much more than how to make scatter plots, bar plot charts, and box plots. You learned a foundation you can use to make any type of plot in ggplot2. To see this, let's add positional adjustment, stats, coordinates to the chord template. Okay, function. There we go. Now, okay. Our new template takes 7 parameters, bracketed words that appear in the template. In practice, you rarely need to supply all 7 parameters to make a graph look because ggplot2 will provide useful defaults for everything except the data, the mappings, and the geom functions. The 7 parameters in the template compose the grammar of graphics, a formal system of building plots. The grammar of graphics is based on the insight that you can uniquely describe any plot as a coordinate of data sets, a geom, a set of mappings, and positional adjustments. To see how this works, consider how you would build a basic plot from scratch. You can start with a data set and then transform it into information you want to display with a stat. Next, you'll choose the geometric pattern, the geometric object to represent with each observation in the transformed data. You can then use the aesthetic properties for geomes. Okay? You then select a coordinate system to place the geomes into. Uh, you would use the location of the object, which itself is an aesthetic property, to display the values x and y variables. At this point, you would have a complete graph, but you could further adjust the positions of the geomes within the coordinate system, a position argument, or split the graph into subplots faceting. You could also extend the plot by using more than one additional layer. Congratulations. You could use this method to build any plot that you can imagine. In other words, you can use the code template that you learned in this chapter to build hundreds of thousands of plots. Okay, so congratulations, you just completed the second, the second, the third chapter of the book. You now know, as it says, you now know a lot about plots, and then I'm going to be bold. I'm going to say that. 75% of the time, you're only going to be using about 50% of the information in this chapter. Okay, but if you understand the way to build a plot, you're going to use the same basic plots over and over and over again. You can even reuse the code over and over again. Okay, like I say, there's plots and functions in this chapter here which I've never used before. I didn't even know about. I didn't know about quick map, okay, or chord map, okay. But again, if you understand the basics of what this chapter teaches, you're well on your way to creating beautiful visualizations. Thanks so much for your time this evening. It's been kind of a long session, 2 hours 52 minutes. But you know what? I think I'm going to cut it in half tomorrow night, and maybe only do a half of each chapter a night, because that's still, you know, uh, 3 chapters a week, right? 5 days, 2.5 to 3 chapters a week. Okay. Thanks so much for all your time this evening. We'll pick it up again tomorrow night at 8 o'clock with the workflow basics, all the data transformations and workflow scripts and so forth. Okay. I think workflow basics is probably a pretty short chapter. Okay. But anyway, thanks so much for your time. Hey, if you get a chance, can go out and look at the car data, MPG data, and look at the diamond data, and try to come up with your own visualizations. Okay. Thanks so much for your time. We'll see you tomorrow night, sharp at 8 p.m. Eastern Daylight Time, for another R for Data Science book walkthrough, chapter 4. Thanks so much again. See you tomorrow night.